In the real world help us determine and understand how larger things are made from smaller ones. In chemistry, it's just to find the concentration of an element in a product, and in physics they can be applied to Newtonian motion.
The function doesn't have any fractions, square roots, or logarithms. Therefore, there are no restrictions. This means that all real numbers are included.
In letter B, we needed to find the x and y intercepts. So to find the x-intercept of the graph, we made the equation equal to 0, so we found the real zeros, which are 0, 0, minus 2, 0, and 2, 0. To find the y-intercept, we substituted 0 in x in the equation, and the result was 0, 0.
To solve letter C, we needed to find the symmetry, which turned out to be even because we used the formula f of minus x equal f of x, and it gave us f of minus x is equal to x to the fourth power minus 4x to the second power.
To solve letter D and E, we had to search for the vertical and horizontal asymptote, but we saw that there couldn't be any of those because our function isn't a rational function.
For letter G, we solved it by getting the derivative of the original equation, and then we made it equal to 0, and isolated x and got the first x, which gave us 0. The second one gave us square root of 2, and the third one minus square root of 2. Then, to make the t-chart, we substituted the values, and we got that f of minus square root of 2 was equal to minus 4, and f of 0 was equal to 0, and that f square root of 2 was equal to minus 4. So with this, we concluded that f minus square root of 2 and f square root of 2 are minimums, and f of 0 is a relative maximum.
For letter H, we found in the second derivative by applying the knowledge of the class, and we used the power rule and got f derivative of x equals 12x squared minus 8. To solve letter I, we had to do the concavity test, in which we got the second derivative of the original and we made it equal to 0. Then we isolated x and got the first x, which gave us square root of 3 halves. The second one gave us minus square root of 3 halves, and then we substituted the values to make the concavity test table. We got that f of square root of 3 halves was minus 3.75, and f minus square root of 3 halves was minus 3.75 as well. These points are the concavity changes that are positive, negative, and positive again, respectively.
To solve letter J, we had to graph the function and decide the range. So we graphed it, and we got the range by observing the graph, which was minus 4 to infinity.
In conclusion, with this project we learned many things involving the topic of calculus, such as how to do the concavity test, which helps us to show the inflection points and intervals, and the ID test, which shows us the maximum and minimum points. This taught us that these kind of formulas may be applied in real-life situations. The derivatives can also be applied in other subjects, such as physics, because it helps us to find some formulas with just one data.
Every day